Okay, hi guys, we meet again. Okay, without any delay, we solve the question for number 2. As the question said, we need to use the first method to determine the direction at the support for the frame. Shown that we have pin support at A and also pin support at C. The B is the fixed support here, okay? Okay, then for the first step we need to do is we need to find the degree of determinacy of this frame. To know the determinacy, we use the formula 3j minus r equal to 0. Right, j is applied to joint and r is applied to the direction. Since there is only one joint here at B, we put here as 1. 3 times by 1 minus 4, since there is 2 pin support and we got 4 reaction here, so we got the answer is equal to -1. The -1 tell us that we are experiencing the first degree of determinacy. Okay. Next, we will draw the free body diagram by applying the principle of superposition. Okay, what is principle of superposition? Principle of superposition is the simplest way to explain is okay. Here, look. When we add the primary and the redundancy structure, we will get the original structure. That is the simplest way to explain what is principle of superposition. Alright. As a result, the pin at A is replaced by a rocker, since a rocker will not constrain A in horizontal direction. Okay. Here is the model of principle of superposition that I already drew. As you can see, this is a original structure and this one is a primary structure without CX. We get rid CX because this is a redundant. And here the redundancy structure. Here clearly you can see there is no real load at the redundancy structure and also there is no load at point A, because redundancy structure, the only load that we apply is CX, and we will also apply the virtual world in this case that we can I will explain about virtual world in the next step. Right, here as you can see, there is 3 formula that we will use in this question. Okay, next we go to the next step. Okay, alright. Oh, sorry, I forgot to tell that the next step, after we find all the primary structure and redundancy structure, we need to create a compatibility equation by referencing to point C. Why point C? Because there is the point that we get rid of the CX. CX is our redundant. Okay, the term of delta C here and FCC here will determine using the method of virtual world. What is virtual world? As I said, we will know the virtual world more in the next step. Okay. Okay, here we go the primary structure. For this delta C, we require application of real load and a virtual unit load at C. First of all, we need to calculate the acceleration and the internal moment by using the equilibrium equation. Alright, as you can see here, for the primary structure, we can find the reaction by using equilibrium equation. Sum of Fy equal to 0. Here Ay plus Cy minus 60 times 6 equal to 0. 60.6 is here, and we got the answer 157.5 kilonewton. Alright, then we use moment at A to know the value of Cy here. The value of Cy is 202.5. To find the internal moment, we need to do a cut section for both frame here, AB, AB, and also BC. Alright. For this internal moment, we label it as M1 and M2. For the first M1, we cut here, and for the second frame, for the M2, we cut here. And there's a result for M1 and also there's a result for M2. Right. Now we go to redundant structure. Okay. For redundant structure, we also need to apply the same method as we did at the primary structure here. As we did at the primary structure here. Wow. Okay, it's okay. For this redundant, we need to apply a virtual word, which is we use 1 as a unit load at point C. Okay. Wait. Okay, as I said, at redundancy structure, we will use virtual unit load at point C. For your information, we will apply 1 unit load for point C to get all the data as primary structure that we did before. This is the same method. We use a equilibrium equation to find the Cy reaction, Ay reaction, and also Ax reaction as well. Okay. Here, when we use moment at A, we got Cy as 0.5 kN, and when we use sum of Fy equal to 0, we got Ay is equal to negative 0.5 here. Then we also need to find the internal moment at the redundant structure. As you can see here, M1 and M2. We also apply the cut section same as the primary structure, and the result is we got M1 equal to negative 0.5x and M2 is positive x. Alright. Actually, there is no difference between redundant and primary structure. Okay, what can I conclude here is we need to find all the reaction here first by using the same method, which is equilibrium equation, and also we need to find the internal moment here, both of the structure, primary structure and redundant structure. The difference is redundant structure, we apply the virtual load. Like I said, we apply 1 unit load at point C as a virtual load. Okay. For the primary structure, we use a real unit load. You see, there's 30 and 60, but here there is no 30 and 60 because we apply the superposition method. Alright, we go to the next step. Okay. Okay guys. Alright. Compatibility equation. Before we solve the compatibility equation here, we need to solve the delta C and FCC here. Why we time FCC with Cs? Because we want to find a total moment in the frame. Alright. Okay. To solve the delta C, we use the data that we got from primary and redundancy structure. Before this, we find the moment and also the internal moment in the compatibility in the redundancy and primary structure. So we just substitute in this formula. Integration of capital M times by smaller m. Capital M is referred to the primary structure and smaller m is referred to the redundancy structure that we apply a virtual world in there. Alright. After we solve this with using this formula and also using our calculator here, we got the answer is 503.25 over EI. Okay. This for delta C. Now we find the FCC by using the formula integration of smaller m times by smaller m, and we got the answer is 27 over EI. After all the data that we got, now we can solve the compatibility equation here. We substitute the data that we got delta C 506.25 and the FCC is 27, so we got the CX is 18.75. okay, now we got one of the reaction in the frame, in the original frame. Okay, now we are near to the end, but before we end, we will go to the last step, which is okay guys, this is our last step. As we find the CX 18.75, now we go to the original structure, which is we have CX here, we put back our redundant 18.75 and then we use the equilibrium equation to find the reaction at the original structure by using sum of fx, sum of f4 equal to 0 and also the moment at A. Okay, then yeah, after we calculate, the answer is we got AX is equal to 108.75 kilonewton, AY equal to 148.1 kilonewton, and CY is equal to 211.9 kilonewton. Okay. Okay, before I forgot, in our case, we apply the moment counter clockwise is a positive and clockwise is a negative. Alright. Okay, actually this all for the solution in the question number 2. However, I will conclude it again in the simplest way. Alright. Okay guys, this is the simple way to understand the first method that we use to solve this problem. First, we need to find the degree of determinacy. Second, we draw the free body diagram using principle of superposition, which is we draw the original, primary and redundant structure. And fourth, we find the external and internal moment for both primary and redundant. For redundant structure, we apply virtual world that we use 1 unit load to point C. And number 5, we make a compatibility equation, which is 0 equal to delta C plus Cx times FCC. And number 6, we substitute data for external and internal moment in delta C formula and FCC formula. Okay, and after we calculate and we substitute data to the compatibility equation, we can get Cx. After we get Cx, we find the remaining reaction using equilibrium equation at original structure. So that's all from me. I hope you guys understand. If not, you guys can rewatch this video and try do it yourself. Good luck and have a nice day.